Hello, in this video, we are going to look at the chain rule, which is a very powerful tool in differentiating composite functions in calculus. Before we delve into the chain rule, let us first understand the structure of composite functions. Composite functions are of the form f of x equals gen of h of x. In this case, we have a function to be the inside of the function gen. So we have our inside function to be the function h of x and the outside function to be g. Now to differentiate f, we first let u or any variable to represent our inside function. So in this case, let's use u to represent our inside function. And we differentiate u with respect to x. That gives us h prime of x. Then our function f becomes a function of u, which gives us gen of u. Now we also differentiate f with respect to u, which gives us gen prime of u. But we know that u equals h of x. We can substitute u with h of x, which gives us gen prime of h of x, which is the inside function. And the chain rule says that to differentiate f of x with respect to x, we have the derivative of f with respect to u multiplying derivative of u with respect to x. Now, derivative of f with respect to u is what we have here. And we get derivative of f with respect to u to be our gen prime of h of x. That's the derivative of gen, which is a function of h of x, then multiplying derivative of u with respect to x, which gives us that, which is h prime of x. So derivative of f with respect to x, which is f prime of x, equals derivative of the outside function. Now we copy the inside, then multiplying the derivative of the inside function. And this gives us our chain rule. This is our chain rule for differentiation. In this example, we have to find the derivative of f with respect to x, given that f of x equals 4x squared plus 2x all to the third. Now, f of x is in the form of composite function with our inside function u equals x squared plus 2x. So, derivative of the inside function with respect to x gives us 8x plus 2. Then our function f becomes a function of u, which is u to the third as our outside function. I'll define derivative of f with respect to u, which gives us 3u to the second. But we know u equals 4x squared plus 2x, so our function derivative of f with respect to u will be 3 multiplying 4x squared plus 2x all to the second. Now, the chain rule says that derivative of f with respect to x equals the derivative of the outside times the derivative of the inside, which in this case, the derivative of f with respect to x gives us our derivative of the outside becomes 3 multiplying 4x squared plus 2x all to the second. Then derivative of inside becomes 4, sorry, becomes 8x plus 2. So we have the dev f prime of x to be 3 multiplying 4x squared plus 2x all to the second multiplying 8x plus 2. In this example, we are to find the derivative of y with respect to x, given that y equals the square root of x squared plus 3x minus 5. In this example, we have our inside function as u equals x squared plus 3x minus 5. And so the derivative of u with respect to x becomes 2x plus 3. Then our function y becomes a function of u, which is square root of u. Then we find our derivative of y with respect to u to be 1 over 2 square root of u. But we know u equals x squared plus 3x minus 5. So our dy over du becomes 1 over 2 multiplying the square root of x squared plus 3x minus 5. And the chain rule says that dy over dx equals derivative of y with respect to u multiplying the derivative of u with respect to x, which gives us the derivative of y with respect to u is 1 over 2 square root of x squared plus 3x minus 5 multiplying the derivative of u with respect to x is 2x plus 3. And this simplifies to get dy over dx equals 2x plus 3 all over x squared plus 3x minus 5. Let's look at another example. In this example, we are to find the derivative of g with respect to x, given that g of x equals the sine of 3x plus 5. So we have our function g to be the sine of 3x plus 5. Clearly, this is a composite function with our inside function u equals 3x plus 5. And we now find the derivative of u with respect to x, that is our derivative of the inside function, which gives us 3. Now the function g becomes a function of u, which gives us sine of u. Now we find the derivative of g with respect to u to give us the cosine of u. But we know that u is 3x plus 5. So the derivative of gene with respect to u becomes the cosine of 3x plus 5. Using our chain rule, the chain rule says that derivative of gene of x with respect to x is the derivative of gene with respect to u multiplying derivative of u with respect to x. And that gives us the cosine of 3x plus 5 multiplying 3. And that simplifies to get 3 cosine of 3x plus 5. Thank you. And for more videos like this, consider subscribing to the channel. Otherwise, see you later.